Hi everyone, welcome to another video lesson. We are on 2-3 day 2 today, biconditional statements. 2-3 day 1 was talking about conditional statements. Along with the conditional statement is the converse, inverse, and contrapositive. We'll be doing more work with those statements today, especially the conditional statement and the converse. The reason why we're going to be dealing with mostly with those two is because a biconditional is a combination of the conditional statement and the converse. So you can write this down in your notes. The biconditional statement is the conditional statement and its converse combined using if and only if. So a conditional statement is written in if-then form, and the conditional is usually symbolized as if P, then Q. And then the converse is the opposite order. So it would be if Q, then P. And so what a biconditional is it combines these two with the words if and only if. And it's abbreviated IFF. This is not a misspelling. If and only if is abbreviated IFF in mathematics. One thing that's important to note, you could write this down in your notes as well, is that if the conditional statement is true, if this part right here is true, and the converse is true, which is right here, then the biconditional is also true. So if you're having a hard time determining whether a biconditional statement is true or false, you could break it up into the conditional statement and the converse. If both of those are true, then the biconditional is also true. So let's practice this. If an angle is 90 degrees, then it is a right angle. This would be a conditional statement. It's written in if-then form. This part right here is called the hypothesis. This part right here is called the conclusion. So now we're going to write the converse, which means it is going to be if Q, then P. So we're going to write this part first. If an angle is a right angle, then it is 90 degrees is going to come second. So that's what you're going to write down right here. If an angle is a right angle, then it is 90 degrees. So now we're going to write the biconditional. We're going to merge both of these two sentences together. So it's not going to be written in if-then form. We're still going to kind of go in order from the conditional statement. An angle is 90 degrees. If and only if it is a right angle. Remember, every biconditional has the words if and only if in them. So here is biconditional. An angle is 90 degrees if and only if it is a right angle. And if you want to abbreviate this IFF, that would be just fine. An angle is 90 degrees if and only if it is a right angle. And to determine whether this one is true or not, we could take the conditional statement. If an angle is 90 degrees, then it is a right angle. That's true. If an angle is a right angle, then it is 90 degrees. That's also true. So if both the conditional and the converse are true, then the whole biconditional would be true. If either part is false, then the biconditional is also false. Let's practice another one. If two lines intersect, then they are not vertical. Okay? So here's our conditional statement. Here's the P, and here's the Q. So we're first going to write the converse. So the converse, we're going to write Q first, then P. So if two lines are not vertical, then they do not intersect. Or sorry, if two lines are not vertical, then they intersect. Sorry, the P part doesn't have a not statement. My fault about that. If two lines are not vertical, then they intersect. Q coming first, then P. So then the biconditional is going to be two lines intersect if and only if they are not vertical. Two lines intersect if and only if they are not vertical. So we combine the conditional statement and the converse using the words if and only if. Let's see if this biconditional is true or false. Let's find the truth value of it. If two lines intersect, okay, so if two lines intersect, then they are not vertical. Yep, no matter how I draw two lines that intersect, they are not vertical. So that is true. Now, the converse also has to be true for the biconditional to be true. If two lines are not vertical, then they intersect. Well, I would say that happens most of the time, but is there one instance where two lines are not vertical and yet they still do not intersect? Wouldn't you say this line and this line are both not vertical? So if two lines are not vertical, my conclusion is that they intersect. These ones are also parallel. They're parallel horizontal lines. So the converse is false. So if either the conditional or the converse is false, the whole biconditional is false. So this two lines intersect if and only if they are not vertical would be a false statement. A false biconditional. Now we're going to practice going the other way around. So I first gave you the conditional statement, we wrote the converse and the biconditional. Now I give you the biconditional. A point bisects a segment if and only if it is the midpoint. Now we're going to write the conditional statement, which is written in if-then form. So if a point bisects a segment, so we can kind of just, put an if at the front. If a point bisects a segment, comma, then it is the midpoint. And that's what we're going to write for the conditional statement. In if-then form, if a point bisects a segment, then it is the midpoint. So we took out the words if and only if, and we put an if at the beginning of the sentence and a then in the middle of the sentence. So now here is my hypothesis, and here is my conclusion. And now we're going to write the converse. So here's if P then Q, and now we're going to write if Q then P. So if a point is the midpoint, then it bisects the segment. If a point is the midpoint, then it bisects the segment. So if we want to see if the biconditional is true, the conditional statement, if a point bisects a segment, then it is the midpoint. That is a true statement. And then the converse, if a point is the midpoint, then it bisects the segment. That is also true. The definition of midpoint is that it bisects the segment. So both of those are true, so we could say that the whole biconditional right here is also true. A point bisects a segment if and only if it is the midpoint. Why don't you guys pause the video, try doing this one on your own, okay? Use this biconditional to write a conditional statement and a converse. Please pause the video and try that on your own. Alright, here's what you should have got. This IFF means if and only if. So you're going to take that out because conditional statements don't have if and only if. They have if at the beginning and then they have a then in the middle of the statement. So if two angles are congruent, comma, then they have the same measure. That is the conditional statement. If two angles are congruent, comma, then they have the same measure. So then when you wrote the converse, hopefully you put this part, the Q comes first in the converse, and then you put the P part second. So if two angles have the same measure, comma, then they are congruent. Hopefully you wrote that down for the converse. If we talk about its truth value once again, if two angles are congruent, then they have the same measure. That's true. And if two angles have the same measure, then they are congruent. Also true. So is the biconditional also true? Yes. If the conditional and the converse are both true, the biconditional is true as well. Two angles are congruent if and only if they have the same measure. There is today's video lesson. Let me know if you have any questions on that when you get to class tomorrow.